I'd like to continue our discussion of scientific notation by simply rewriting these numbers that I have down here first. The first two into their number equivalent and the next two into their scientific notation equivalent. So for the first one, 2.54 times 10 to the fifth, as we were evaluating those powers of 10, there was kind of a nice pattern that showed up. And the nice pattern, I hope you realized, was that this number right here, 2.54, when multiplied by 10 to the fifth, just means that I need to move that decimal to the right 5 places. That's the ultimate effect of what happens. So I'm just going to copy down 254. And if I've got 254, that means I've moved the decimal 2 places over already. I need to go 3 more places over, so I'm going to add a 0 for each of those places. So once again, to check, this is where our decimal started. Times 10 to the fifth, move it over, 1, 2, 3, 4, 5. It ends up right there. And there's the whole number that it comes out to. Okay. Very nice, quick and easy expansion. That's why scientific notation is so nice. Can you imagine if these were 8 to the power of something, or 16, or whatever else? It's not quite so simple. Although there may be applications for other powers. So let's take a look at this one. Remember, if I have 10 to the negative fifth, this means essentially that I am dividing 2.54 divided by 10 to the fifth power. And so if I'm dividing this by some large number, then that means this number is going to get smaller. And the cheap result of all this is I just move the decimal place to the left. I have a negative exponent on the power of 10. I move the decimal to the left. So I'm going to put 0 point. How far do I have to move it to the left? From here, I have to move it 5 places. So the first one gets me here, and then those other empty places need to be taken up by zeros. So I've got 1, 2, 3, 4 zeros, and then 2, 5, 4. So again, just to check, this is where our decimal started. Times 10 to the negative fifth, I move it back 1, 2, 3, 4, 5. Okay. And there we go. Let's go the other way around. Let's start with the number and turn it into scientific notation. Now remember, scientific notation says that the number in front has to be between 1 and 10. It can include 1, but it can't include 10. Now, I'm only saying that to tell you where to put the decimal when I turn it into scientific notation. For example, I could put a decimal here and call it 50.0234 times 10 to the something. But because of the strict definition of scientific notation, I need the decimal here so that it's 5 point. Notice that that 5 is between 1 and 10. 0, 0, 2, 3, 4, and now I need to determine what the power is. Times 10 to the what power? So I like to ask myself, what power would this have to be to get back to that number I started with? Well, it would have to be a positive power, because if I started here, I need that decimal to move to the right to end up with that whole number. How many places do I need it to move to the right? 1, 2, 3, 4, 5 places. So I'm going to erase this and say, okay, this needs to be times 10 to the positive fifth power. And those are equivalent expressions. For the bottom one, again, I'm going to start with a number between 1 and 10. So it's going to be, in this case, 5.12 times 10 to the something. And I need to figure out, again, how to get back to the original expression. So from here to there. Well, this number is smaller than this 5.12. So what that means is that this has to be a negative power of 10. I would be moving the decimal to the left some number of places. So let me just put my finger here. How many places? 1, 2, 3. That means this has to be 10 to the negative 3. Piece of cake, right? And that's why we love scientific notation. Now let me give you an example where something looks like it's in scientific notation, but it's not quite in scientific notation. And this is sometimes where it gets a little tricky. So let me highlight it for you to hopefully demystify it. Suppose, for example, we had 0.0023, I'll put another number in there, times 10 10 to the 8th. Okay. So that looks like it's in scientific notation, but it's not in scientific notation because this number in front is not between 1 and 10. It's less than 1. So there are different ways to handle this, but one way to turn this number into a number into legitimately scientific notation would be to first turn this first number into a number in scientific notation and then go from there. So if I'm just looking at 0.0023, then I would call it 2.3 times 10 to the negative 3. Just verify that for me real quick. If you had the decimal here, you move it back 3 places, that's the same thing, right? Now I still have this times 10 to the 8th on the outside. Okay, we're almost there. This gives me the 2.3. Okay, so this becomes 2.3 times 10 to the what? Well, remember our exponent rules. When we're multiplying two exponential expressions that have the same base, we can add the exponents. Negative 3 plus 8 is 5. So here is the legitimate scientific notation way of writing that number that we started out with. Now, are they really the same thing? Is 0.0023 times 10 to the 8th the same thing as 2.3 times 10 to the 5th? Well, here's a quick check. If I turn this first thing that looks like scientific notation into just a decimal number without any power of 10, then I would be moving that decimal to the right 8 places. Right? Now compare that to this, 2.3 times 10 to the 5th. If I took the decimal here and moved it to the right 5 places, you'll notice that in fact you end up with the same exact number. So they are the same number. This one is in scientific notation. The first one is not. Here, let me do one more like that. Let's go the other way around. Suppose we had something over. Okay, so let's say we had 230 times 10 to the 8th instead. And I wanted to turn that into a number in scientific notation. Again, I don't want 230. I need a number between 1 and 10. So I'm going to start by turning 230 all by itself into a number in scientific notation. I could write 2.30 or just keep it as 2.3. It all depends on the specification that you need, but let's just call this 2.3 times 10 to the what? 10 to the 2. Because if I had the decimal here and moved it 2 places to the right, that would give me 230. So it must be the same as this. I still have times 10 to the 8th there on the outside. Now I'm going to use the rules of exponents to say that this is 2.3 times 10 to the 10th in the end. And that's it. So be careful with these two cases that I stated on the right. When something looks like it's in scientific notation, but it's not, be careful with that relative to what you started with in the beginning. And I hope I've cleared things up instead of mucked them up. But please let me know. Let me know if we need more explanation here. Stay tuned for some additional examples.